What is hydrogeology? It is the comprehensive study of groundwater, its distribution, and evolution through time and space. Under regional geology, geohydrology studies water behavior in geological environment, according to hydraulic laws. It includes shaft hydraulic, that is drilling, to obtain water for different purposes, and environment behavior control, according to the kind of drilled material. Both specialties associate regional and local geologic information, superficial and subsoil to contribute optimum groundwater use in favor of sustainable development. Water and its importance. Water is the substance that allowed human to establish in specific areas and progress in different tasks. It's the main component of living matter, so it constitutes 50 to 90% of the mass of organisms. The freezing point of water is 0 degrees Celsius, and the boiling point is 100 degrees Celsius, to atmospheric pressure of 760 mm Hg, and a temperature of 4 degrees Celsius, reaches at maximum density. Polluted water supply may contribute to the transmission of gastrointestinal diseases, such as cholera, typhoid fever, dysentery, and gastroenteritis, as well as viral diseases as infectious hepatitis. Also, the lack of water for personal hygiene and environmental sanitation is a contributing factor to the spread of these diseases. So it is of vital importance for all countries to conduct intensive and extensive hydrogeological studies that allow knowing precisely the distribution, quantity, and quality of water available in their territorial domains to optimize the sustainable development planning. Our planet experiences a progressive decrease in the quality and availability of water. A substantial percentage of rural and urban population of the world does not have direct access to clean water. In some regions, reserves have been polluted at different intensity levels with toxic chemicals. Water perpetual motion between Earth and atmosphere is known as hydrological cycle. Water vapor is produced by evaporation at land surface and in water bodies and transpiration of living beings. This vapor circulates through atmosphere and falls as rain or snow. In condensation and precipitation, rain or snow absorbs from the atmosphere different amounts of carbon dioxide, other gases, and sometimes radioactive substances, as well as small amounts of organic and inorganic groundwater. Groundwater is located below the surface, confined to a pressure equal to, or greater than, atmospheric pressure. It saturates the rocky medium, through which is moved and stored. Liquid may arise in open spaces of lithological units, such as gaps between crystals or grains, failures, joints, lithological contacts, and other discontinuities, and in rocks cavities caused by cooling, dissolution, or weathering. Movement and groundwater storage depend on the thickness, texture, and rock structure that constitutes the Earth's crust. Besides the physical ability of water to move through a permeable medium, also, the imbalance caused by the interaction of different forces, such as gravity and differential pressures, makes the water remains in constant motion, creating deposits, which supplies wells and springs, keeping the flow of some streams during periods of drought. The lithological units, that have a greater capacity to store and provide the vital fluid, are called aquifers. These may be placed near surface of earth, contained in permeable rocks, or confined to deep fractured or failed rocks. Aquifers are supplied or recharged by water that has fallen on the surface of earth as a result of rainfall, hail, or snow, and dispersed through soil, sand, gravel, and fractured rocks. So water remains stored in one or more geologic formations, consisting by permeable rocks, which hold back or let liquid pass. An aquifer of uniform shape and texture, and free-flowing, takes the form of an inverted cone, known as the depression cone. This has its apex in the dynamic water level in the well during pumping, and the cone base in the static water level